It's okay. Guys, today we're going to talk about similarity proofs, okay? When we talk about similarity proofs, we want to think about how we can organize the deductive reasoning of a geometric proof. We're going to try and write a two-column proof. That's our goal. We're going to prove geometric theorems by using deductive reasoning. Okay? A lot of stuff in there, all right? Let's get to it. You don't have to write this down. Let's just think about this. When I write a proof, what I have to do is justify each logical step with a reason. We can use symbols and abbreviations. They must be clear enough so that anyone who reads your proof will understand them. Right? I tried this in the last class. I don't know how successful it was. I'll try it again with you guys.
And I scared her because when she went to eat the steak, I moved.
You shouldn't do that. All right. Here is what we've got today, guys. Today, first off, we're going to talk about theorems. Any statement that you can prove is a theorem. That's nice. Okay? Any statement that we can prove, we call it a theorem. Once we've proven a theorem, we can use it in later proofs. I need you to write down a couple of them. First one's called a linear pair theorem. If two angles form a linear pair, then they are supplementary. We'll talk about that. Also, what we call the congruent supplements theorem. If two angles are supplementary to the same angle, then the angles are congruent. Or to two congruent angles. Okay? Make sure you get those definitions written down. Okay? So when I talk about linear pairs, I'm talking about what? I'm talking about a pair of angles, okay, that are supplementary. Why are they supplementary? Simple. They're on a line. That's easy. Linear pairs. Pair indicates how many? Two. On a line. Okay? But congruent supplements is a little different. There's a little transitive property involved. If two angles are supplementary to the same angle, then the two angles are congruent. 1 and 2 are supplementary. Coincidentally, 2 and 3 are supplementary. What do we get from that? 1 and 3 are congruent to each other. Okay? 1 and 3 are congruent to each other. Okay? Would 1 be supplementary to... Sorry. Let's say angle 1 was 100 degrees and angle 2 was 80 degrees. Are they supplementary? Why?
180.
Say it out. 100 plus 80 is 180, right? If 2 is 80 degrees, how much does 3 have to be if it's supplementary to 2? It's got to be 100, right? Did you notice that? 100 angle 1 and 100 angle 3, right? They're congruent. They have to be, okay? All right. This little logic game we play, we're going to do what's called a two-column proof from it. Geometric proof begins with given and proof statements, which restate the hypothesis and conclusion. In a two-column proof, you will list the steps of the proof in the left column, and you will write the matching reasons for each step in the right column. We call these statements and justifications, or statements and reasons. Statements will be on the left, reasons will be on the right. I'll have a statement and then a reason. Statement and then a reason. They will start with the given information and end with what I'm trying to prove. I'm going to move on. Alright, what might this look like? It'll look like this. This will be probably the easiest proof we ever do. Okay? Fill in the blanks to complete the two-column proof. I'm given, let's just say that I'm given line segment XY. That's all I'm given. I'm trying to prove that XY is congruent to XY. It's another way of saying xy is congruent to itself. I start off every proof with the given information. If nothing else, get this out of today. You start with the given. Okay? All right? You don't have to write this down just yet. We'll do another one. From here, I can here's what I know. I know that xy equals xy. How do I know that? The reflexive property tells me that. We did that last week. We said that any segment was equal to itself. Sometimes it might help to draw a visual. I'll do that here. Here's x, here's y. Whoa. Okay? I've got three triangles. In triangle AYX, YX has a certain, let's say it's 6, okay? In triangle BYX, what is the measurement for x gonna, or for YX gonna be? It's gonna be 6, right? It's the same. It has to be the same in both triangles because YX equals itself. Well, if it's equal to itself, that means it has to be congruent to itself. Okay? So hopefully what you're seeing is that equality is this aspect of congruency. Okay? Congruency, wholly similar and wholly equal. Okay? That's how I get this proof. For those of you writing it down, I told you don't worry because it will get harder. Fill in the blanks to complete the two-column proof of one case of the congruent supplements theorem. Given that 1 and 2 are supplementary and that 2 and 3 are supplementary, I'm trying to prove that angle 1 is congruent to angle 3. Guys, this is what you'll see today. This is what it'll look like. Let's go through our logical reasoning. I told you you start with what? The given. Traylon, what is given here? Supplementary. And what else? Good. Those poor first block kids. We spent about 5 minutes before somebody could answer that for me. Okay? How do I know where to look for the given information? Scarborough, you think it'd be pretty easy, right? The word given with colon right after it, right? That's what's given to me, okay? So when I am writing my proof, I start with the given information. Guys, here are 1, 2, 3, 4 statements. Which one is going to go with given? A. It should be like nada, right? Mr. Hobbs, this is what is followed by the given information. So where it says given, that's where I'm going to put this. So this would be A. Okay? This would be A. Next, I'm going to take a logical step. Tucker, if things are supplementary, does that mean that they have a sum of 180? Yeah, so watch all I do here. Okay? 1 and 2 are supplementary. That means that the measure of angle 1 plus the measure of angle 2 is 180. 2 and 3 are supplementary. That means that the measure of angle 2 plus the measure of angle 3 equals 180. How do you know, Mr. Hobbs? That's the definition of supplementary. That's what supplementary means. The definition of supplementary angles means angles have a sum of 180. That's all that we've done, right? We've got to go like baby steps by baby steps, okay? Well, if 1 plus 2 equals 180 and 2 plus 3 equals 180, what does that mean about 1 plus 2 and 2 plus 3? They equal each other, right? And I can use what we call the substitution property to tell me that, right? Holly, is 180 equal to 180? Yeah. So if, look here, if the sum of these angles is 180 and the sum of these angles is 180, I can set those angles equal to each other, right? That's all I've done there, okay? Got a lot of questions and looks about that the first time around. That's all I've done. That's how I've substituted. from here, remember, this is what I'm trying to end up with, right? From here, there's something rather fishy about this particular, equation, right? What's on both sides of this equation? Angle 2, right? Angle 2 is equal to itself, correct? Yeah, it's equal to itself. The reflexive property says this has to equal this, okay? You got me? Angle 2 has to equal angle 2, all right? Here's what I can do. If I'm trying to get to this final step, this is where people are like, guys, what do I do to angle 2 here? Subtract it. I subtract the measure of angle 2 from both sides of the equation, correct? All right? Subtract angle 2 from both sides of the equation. What would I end up with? Angle 1 is equals angle 2. See that? See that right there? Okay? How did I get there? What did I do?
The 2 out.
Yeah, and how did I take the 2 out? I subtracted it. That's why C is your subtraction property of equality, okay? This is meant for analytic geometry and not geometry. I kept it all in here, mainly because I wanted to use these similarity proofs, okay? I want y'all to see them, all right? All right. If 1 is equal to 3, what does that mean about angle 1 and angle 3? They're congruent, right? Correct? And that was what I was trying to prove all along, correct? This would be statement B over here, that angle 1 is congruent to angle 3. Okay? Let's use some student skills here. What did I start this proof with? The what? Everybody say this with me. I start with the given. Say it again. Start with the given. What did I end this proof with? Prove. Right? The last statement that I made was what I'm trying to prove. So, end with the prove. Say it with me. End with the prove. End with the prove. Start with the given. End with the prove. Is that simple? Okay? It's that simple. Alright? That's the simple part. The hard part is like 2 through 5, right? Okay? The hard part's going to be 2 through 5 today. Alright. Use the, see what I did here? 1 and 2 are supplementary and 1 is congruent to 3. I'm trying to prove that 3 and 2 are supplementary. We call this a paragraph proof. You know what? I don't like paragraph proofs, so I don't really make you do them. Boom. Okay? Use the definitions of supplementary and congruent angles and substitution to show that measure angle 3 plus measure angle 2 equals 180. By the definition of supplementary angles, angle 3 and angle 2 are supplementary. It's basically just writing the things that we want you to write in a 2-column proof, so let's just do 2-column proofs. That's what you're going to see. That's the hard part, okay? Alright. One, how would they put this in a 2-column proof? Like this. Do it like this. What do I start with? What do I end with? The prove, right? What's in between is what matters. 1 and 2 are supplementary. What does that mean? They have a sum of 180, correct? How do I know that's true? Mr. Hobbs taught me the definition of supplementary angles, okay? Because he told me if I didn't have it down by Friday, then I would not get it correct on the quiz, right? Got me? Get that definition down. You got till Friday, okay? Yes, you have until May, but you really need to do it by Friday, okay? Angle 1 is congruent to angle 3. Does that mean that they're equal? Think about it. 1 is congruent to 3. Does that mean that they're equal? Yeah, because the definition of congruent angles includes the fact that congruent angles are equal to each other. This is where you guys are going to have to just right now, this next step is where for right now you might look at it and be like, home fry, you sure about this? Okay. 1 plus 2 equals 180. 1 is the same as 3. What does that mean? It means 3 plus 2 equals 180. The measure of angle 3 plus the measure of angle 2 has to equal 180. How did you get that? If I started with angle 1 plus angle 2 equals 180, and I told you that angle 1 is equal to angle 3, that means that, through substitution, angle 3 plus angle 2 has to equal 180. Anytime two angles have a sum of 180 degrees, they are considered to be what? Supplementary. Okay? Then y'all wish to do tacos and quesadillas again? Those were more fun. Last one, and I'll get you on your classwork. Write a justification for each step. Given that the measure of angle ABC is equal to 9 degrees, then the measure of angle 1 equals 4 times the measure of angle 2. Okay? Miss Farr, how do I start this proof for the what? What do you think the justification is for number 1? Yeah, it would. It'd just be given, right? That's the easy part. Guys, I will give you credit for doing that, and I kid you not. I will give you credit for saying given. If you can transfer the given information into the first step, I will give you credit. Okay? That tells me there's brain activity and you are trying. All right? That's how I can grade you on these. All right? You start with the given. Okay? If, let's see here. If ABC has angle 1 and angle 2 inside of it, that means I can take the sum of angle 1 and angle 2 and get the measure of angle ABC. Why?
Oh, we're not congruent, but like they equal 90 degrees.
Okay. What?
The definition of complementary.
Okay, we're getting closer. That'd be great. This is going to take you back to the beginning of the year. We call this the angle addition postulate. The angle addition postulate tells me that the sum of two interior angles equals the measure of the angle that creates them. Okay? Alright. If I start with 1 plus 2 equals ABC, how do I get to 4m, 4 times the measure of angle 2, plus the measure of angle 2 equals 90? It's your best friend in all of this. Okay. Angle 1 is also known as what? 4m2, correct? Angle ABC is also known as what? 90, right? We call this principle substitution. If I substitute 4m times angle 2, 4 times the measure of angle 2, and I substitute 90 for the measure of angle ABC, that's what I end up with, that particular equation. So the justification here is substitution. Okay? Now, let's make this into an algebra problem. I got 4 times the measure of angle 2 plus 1 times the measure of angle 2. How many measures of angle 2 do I end up with? Pi, right? How many times if we drew this out, it would be measure of angle 2, measure of angle 2, measure of angle 2, measure of angle 2, and we add one more to it, right? That would be 5 times the measure of angle 2. Okay? How did I go from here to here? They're going to call this simplify. Okay? If you want to call it combined like terms, I'm fine with that. Alright? Out of all this mess, okay, out of all this mess, I end up saying the measure of angle 2 equals 90. How did I do that? How did I go from here to here? Didn't subtract. I did what? Divided both sides by what? Perfect. You see it, right? If I divide both sides by 5, whoa, by 5, I'm going to end up with this canceling out and this becoming 90 divided by 5, which is 18. Okay? If you want to call this division property, you can. If you just want to say divide, you can. Well, P-E-R-T-Y. All right? Okay. Question. What's the measure of angle 1? If the measure of angle 2 is 18, the measure of angle 2 plus the measure of angle 1 has to be 90. And the measure of angle 1 is 4 times the measure of angle 2. It's 72, isn't it? You old dog. How'd you get that? 90 minus 18 would work, correct? Right? Remember, this has to be true, correct? Right here, that has to be true. 1 plus 2 has to equal ABC. ABC is 90. 2 is 18. That means that x plus 18 is 90. I subtract 18, I get 72, right? Oh, right there. Okay? What's another way I could do it? 18 times 4. I don't even need a calculator. 4 times 18 is 32, right? Carry the 3. 4 times 1 is 4, plus 3 is